Hi everyone, so this is question 7. I'm not sure where is it from, but let's look at the question. Object A and B of masses 1.5 kg and 2 kg respectively. So I've labeled it here and here. Are on a horizontal smooth plane as shown in figure 3. B is at rest. Okay, so we should label from B is at rest, so UB is equals to 0 ms negative 1. But A is moving at a constant speed of 4 meter per second towards B. So I can say UA is equals to 4.0 meter per second. After collision, so this is the first event, there's a collision that happens. A moves in the opposite direction. So before that, let's say it's moving to the right, then now it's moving to the left, opposite direction at a constant speed of 2 meter per second. But even though the speed is indeed 2 meter per second, but if we are dealing with stuff in chapter 2 and chapter 3, chapter 4 also actually, but chapter 4 is a bit different, we will need to do some assumption with our direction. So right is positive, left is negative, is what we usually do. So even though the speed is indeed 2 meter per second, but because it's moving towards the left, you should attach a negative sign in front of the 2 meter per second. While B moves is a constant speed towards a wall. So they didn't tell you what is the constant speed, but they just tell you it's a constant speed. When B strikes the wall, so this is event number 2 already. When B strikes the wall exerts an impulse of magnitude 15 Newton per second on B. Okay, so there will be an impulse by wall on B here. Okay, later we will draw the direction. 15 Newton second on B. Determine the speed of B after B has collided with the wall. Okay, so if you look at the diagram that I draw here, there are 2 events that we need to deal with. Usually in chapter 3, this is chapter 3, momentum and impulse. Usually we deal with collisions. Most of the time it's collision or something that happens for a short period of time. So there are 2 events here. One is when A collides with B, the other one is when B collides with the wall. As we can see here, A is just playing a supporting character, B is the thing that we care more about. Okay, so oh, did it tell anything else? No. Okay, so we know that there are 2 things that we don't know. One is what is VB, then another thing that we don't know is when after this ball B collides with the wall, what is the speed when it's going back, when it's being reflected back. Let's call it VBF then, VB final, when it's going back. Okay, so there are 2 things that we don't know, and based on our usual experience, it's usually more systematic if we analyze it chronologically. Means when we analyze the first event, then only we analyze the second event. So first event is a collision between 2 balls. Usually we know that we need to analyze it using principle of conservation of momentum. So yes, principle of conservation of momentum, you start with sum of PI equals to sum of PF. Then you write down a formula. There are 2 objects here. One is object A, one is object B. Then if you substitute everything according to the situation in the diagram that I draw up there, you should be able to get the answer VB equals to 4.5 meter per second. So as you can see here, the answer that we get is positive. That means by VB is going to the right, which is correct. And you notice carefully, VA here is negative, just like what I write up here. So we know that the velocity of the ball moving to the wall should be 4.5 meter per second. But now this is not what they are interested in. They're interested in the speed when the ball being reflected off the wall. Okay, so based on our logical sense, we will know that the ball right now is moving to the right, but after hitting the wall, it should be changing to the left hand side. So if you want a ball to be changing from moving to the right, you want to change it to moving to the left, it means by you have to apply a force that is towards the left hand side. Okay, think of it like this. If let's say a bowling is coming towards your direction and you want to reverse the direction of the bowling, you have to push the bowling ball in the opposite direction to the motion of the bowling ball. Let's say the bowling ball is coming towards the right towards you. It's moving to the right towards you. So if you want to reverse the direction, you have to push towards the left. Okay, that's a reasonable thing to think of. So because the force have to be pushed to the left, that means by the impulse have to be pointing towards the left as well. So with that said, we should know that this impulse J here should be pointing towards the left. Okay, again, we have to be very careful when we talk about impulse. This is the impulse by the wall on B. Means by the wall is exerting this force to push the ball to reverse its direction. If you really want to think of it more carefully, you can draw a free body diagram and you see that when this ball touches the wall, the normal force will be pointing towards the left as well. And this normal force is exerted by the wall on B. So with that said, we can know that the impulse is pointing to the left. So now if we look back to this student's question, the student asks, the wall exerted impulse 15 Newton second on B, but I can't get the answer unless I use negative 15 Newton second. So when I ask what do you think, they say it should have a negative sign in front. Okay, what this student has said is correct. Okay, and it doesn't conflict with the question at all, because if you look carefully at the question actually says exert an impulse of magnitude 15 Newton per second. That's what they mean. They didn't really specify the direction of the impulse. They just tell you that the strength, the magnitude of it is 15 Newton per second. So if you use your logical thinking, you deduce that this impulse should be pointing towards the left. After making that deduction, you follow this sign convention, and because it's left, you add a negative sign in front of the impulse. Therefore, when you use your impulse momentum theorem to solve a problem, you put in a negative sign. Because this is the magnitude 15 Newton second, the negative sign represents the direction. The impulse is pointing towards the left hand side. So it's impulse momentum theorem, the change in momentum. You have to be more careful with the change of momentum. Initially it's moving to the right, so it's a positive value, negative sign, positive value. But the final come out should be a negative value, means by finally the ball should be moving towards the left. Okay, so everything still follow the sign convention up here, no problem. Okay, just one thing to be careful of. When I say the impulse by wall on B is pointing to the left, we can also know that the impulse by B on the wall is pointing to the right. Okay, so this is because of Newton's third law. If the wall is exerting a force on B, then at the same time B must exert an equal amount but opposite direction of force on the wall. Okay, therefore if this impulse is towards the left, if you switch the B and the wall and you now make it impulse by B on wall, then it should be pointing to the right. So if it's pointing to the right, you know that it should be a positive impulse. Okay, so you have to be careful with impulse momentum theorem. Impulse momentum theorem is the impulse experienced by an object equals to the change in momentum of the object. That's why you see it's on B, it's not by B. It's on B, it means by B experienced this impulse exerted by the wall. B received the impulse, and because it received the impulse, it undergoes a change of momentum, which we can calculate using this part here. Okay, so be very careful when you're dealing with chapter 3 signs. Negative left, positive right is usually what we do, and be careful with the impulse is by what, on what. You have to be very careful to determine it, because impulse momentum theorem says the impulse experienced by an object equals to the change in momentum by that object itself, not by the object, a change in momentum of the object itself. Okay, I repeat, the impulse experienced by an object is equals to the change in momentum of the object itself. Okay, so that's how you solve the question. There's no problem with what the student thinks, everything is fine. So be careful with the word magnitude. And yeah, that's all for this question. Thank you very much.